The lab we're going to do today is called the Names and Formulas of Ionic Compounds. Now, this sheet is going to look a little different than other sheets that you've seen, but it should work just fine. So this is the name and formulas of ionic compounds. Basically, what you're going to do is you're going to observe the formation of compounds and write their names and their formulas. We have already talked about nomenclature, which is just kind of a fancy way to name things. But one of the things I want you to notice here is that we're really going to be looking at precipitation reactions. And so in the background, it says, how do chemists identify when a chemical reaction has occurred? Now, there's a lot of ways to do this, but precipitation reactions are reactions where two solutions are combined and an ionic compound is formed that's insoluble in the solution. So a lot of times to us, this looks really cloudy, and so the next sentence says the new compound either immediately precipitates to the bottom of the reaction vessel or makes a solution cloudy, and you can tell that a reaction has occurred because the color and transparency of the solution has changed. So in this experiment, we're going to combine a lot of different chemicals and look for evidence of a compound of chemical reactions and compounds forming. You are going to name these compounds using IUPAC nomenclature to give each ionic compound its official name, and you're also going to write the chemical formula. Now, you are going to do this in these boxes here. And so I want us to kind of look at what we're seeing. So this is a matrix, and what we're going to see here is there's a silver ion, and when we add sodium sulfate, and I apologize, my dad is in the middle of Christmas shopping. So what we're going to see here is there's silver and there is sodium sulfate. And what we're going to see is that the silver is going to react with the sulfate. And so the ion that you're really interested in here is the one that is in the parentheses. That's the reacting ion. The other ion, the sodium, isn't going to react. We call that a spectator ion. So each cell, which is here, should include a description of what you observed when the reagents were mixed. So if it formed a precipitate, what color precipitate are we looking for? That's really what you need to write down. Then you need to put the correct chemical formula and the name for all the solutions that turn cloudy. So if when we react silver and the sulfide ion and it turns cloudy, you're going to tell the color, then you're going to tell the correct chemical formula, and then you are going to give the full name. Okay. Now, if it doesn't react, if that solution stays clear, then you don't have to do any of those things, and all you need to do is write NR, which means no reaction. We are going to perform this lab in the inorganic lab. So again, this is one of those situations where this was done in a desktop version, and that version has been updated. So the instructions I'm going to give you here are a little different than what you see written. So we're going to come over here, and we're again going to be in this inorganic lab. And so I've pulled up the inorganic lab here, and it says double click on the test tube from the box on the stockroom counter and place it in the test tube stand. So we're going to double click here, and then there's our test tube kind of here. And so it says, so all you do is double click, and then you can then click on the bottle of silver metal ion. So we're going to come here and we're going to click on the silver, and so we're going to do everything in this first row, first column here. So we're going to come over here and we're going to do silver, and we're going to put silver right in here. Then it says, click on the divide tube on the bottom 4 times to make 4 additional test tubes containing silver plus. So we're going to come here and we're going to see the divide. So you see a decant here, which just means to pour, but divide is the one that we want here. So we're going to click that 4 times. 1, 2, 3, and 4. Okay. And so now it says, right, you're going to click on the sodium sulfide bottle. So what we're going to do is the 4 vials of, or test tubes of silver are going to be, so there's one in the stand here, and then there's 1, 2, 3, 4 that are on the blue bit here. Okay. And so we are now going to react each one with these ions that are shown here. So we have silver, and we're going to look for the sodium sulfide. So the sodium sulfide is here, and you can see that when you put your cursor over the sodium sulfide, you should see a dropper. So you're going to click on that, And this is what a precipitate looks like. So the precipitate here, the way you're going to describe that is going to be the color. And so I would say that's black or brown, either is fine. So you're going to put here brown. Then the next thing you're going to do, so that's what we've seen a precipitate, the color is brown. The correct chemical formula. Now the correct chemical formula is shown here. It's Ag2S. We're not going to write sodium. Remember, that's a spectator ion. It's just going to kind of hang around. So then you're going to write the Ag2S here. Now what you're going to do is you're going to name that solution. So that solution is silver sulfide using our ionic nomenclature rules. Remember, we define things that are ionic because they're most of the time a metal and a non-metal. Really, we know it's the charges that are attracting each other, and there's some, of course, exceptions that metal and non-metal rule with our polyatomic ions. So we name this silver sulfide. Silver is one of those ions that even though it's a transition metal, it is in the boot, which I talked about in our screencast in class. But what that means is that it only has one charge. So even though it's a transition metal ion, we do not use a Roman numeral with it. So that answer will just be silver sulfide. So we have filled out the first column here. And so I want to show you how to go to the second column here, where we're going to react sodium chloride with silver. And so we're going to move this over here, right? Move this up here. Then we're going to come over here and we're going to add sodium chloride. So this would be a white precipitate, so we would put white there. AgCl would be the chemical formula, and then the name of that would be silver chloride. We're going to move this over here. We're going to put our next one up here, and our next one is sodium sulfate. And the sulfate ion, so this is a polyatomic ion, there's more than one atom, and there's an overall charge for the whole thing. And so we're going to come here to sodium sulfite and we're going to add that. Now I want you to notice that here we didn't see anything change. It stayed colorless. It's not cloudy. It didn't change. It's not cloudy. Changing color can sometimes happen, but cloudy is really what we're looking for a precipitate. There's no solid down here. Okay, so there's nothing that changed. This would be an example of a no reaction. So you don't have to do anything in this box except write a big N and an R, and that's it. And then you go to the next one, okay? So I like to walk through at least the first three with you so that you can see two that react and know what to write, and then one that doesn't react and know that you need to write no reaction here. So once you do that, that's this question. It's all written up here. So, but what you need to answer here is, did you notice any patterns, right? So you need to look and say, okay, were there any patterns? Did silver all form the same color? Was there a color, a precipitate pattern, those types of things? That's what you're looking for there. So this data, you're going to make some observations about it as a whole. And then that is it, right? So you'll work through this and you'll turn it in. As always, if you have any questions, please feel free to reach out and email me.